Okay, lecture 11, we'll talk about lyophilization or freeze drying process in drug manufacturing. Okay, so you see this picture of vials, drug vials, and maybe an ampoule with freeze-dried drug product. We call this white fluffy freeze-dried material, the drug condition is drug cakes. Okay, so if these cakes are in this good looking white easily identifiable form that is not collapsed or kind of disengaged from the vials or container, primary container, that's in good condition, pharmaceutically elegant condition, so that is probably good freeze-dried product. Okay, so first freeze drying process or lyophilization. Okay, so lyophilization means a process to produce a product that loves a dry state. That's what this word means. Lyo is a dry, philization, philia is love, right? So loving dry condition, that's what lyophilization is. But in terms of describing the process, actually if you look at the freeze drying process, normally you freeze your drug first and then you dry it to remove water vapor. So in terms of describing the process, freeze drying is a better word to describe the entire freeze drying process. Okay, but anyway, some people say lyophilization, some people say freeze drying, but those two words are used kind of interchangeably. Okay, so then what does that mean, freeze drying? So what it means is you are removing the water molecules selectively from your drug. Okay, so how do you remove those? If you freeze your drug, you know water will become crystallized, right? Water becomes ice, and then if you want to remove it, how do you remove it? Ice doesn't come out of your drug easily, right? You can remove it by sublimating water crystal. Sublimating, what does that mean? You can change the frozen state of ice, the water, into vapor form directly without going through liquid form. So you can vaporize crystallized water, and then you can remove water molecule as vapor form. That's what freeze drying process is. Okay, so that's how the process works. Then why do you have to do that? What's the advantage of freeze drying your product? Okay, so these are the main advantage. So we probably talked about the history of parenteral or injectable drug products. In that history, we said something about 1935. There was a first freeze-dried human plasma developed. That's during the maybe World War II, because a lot of casualties in European countries or Pacifics, America tried to send the blood plasma long distance without getting that maybe damaged. So that's how they studied the freeze drying process to preserve the plasma for long term without getting them degraded, right? So then what is the main benefit of freeze drying your product? Okay, so if you freeze dry your product, okay, you can keep your drug for long shelf life, so at least 2 years or longer. Okay, at controlled temperature. Okay, so you can stabilize, you can store a longer time. Okay, not only that, if you remove water, of course, your product weight will be much lighter, right? So then if your product is lighter, then in terms of transportation and storing your product, that'll be less costly because the weight will be much less, right? And not only that, so that extended shelf life is due to the fact that there's no water in your drug product. Okay, so by removing water, you are removing the possibility of hydrolysis condition. So hydrolysis means what? There's a water molecule involved in the chemical process. That's what hydrolysis is, right? Once your drug is freeze-dried, normally that can be stored without refrigeration. Okay, so think about maybe exporting your drug to maybe the someplace in Africa or so other parts of the world where the logistical I guess capacity is not very good. I mean, they don't have maybe good refrigeration condition or transportation condition. Then yeah, freeze-dried products are much more stable, so it is much better, much advantageous, right? And then if you freeze dry it, you'll get less contamination problem because you're removing water, and then extractable, leachable issues in the formulated bottle, because there's much reaction possibilities between the container and the water. So these are a lot of good benefits for freeze drying your product. And the question is, what's this picture? Do you see the fishes being dried there? But it's done during the winter time, very cold condition. So if you have a fish, kind of frozen fish during the winter time, these fishes after frozen, the liquid is evaporated. So it's kind of primitive freeze drying. By drying your fish this way, freeze drying your fish, you can store your fish long time, maybe months and months, maybe sometimes a year. Those are freeze dried fish, the food material. Okay, so what's shown is in the primitive ways, humans have been using freeze dried product, especially food material, for a long time. Okay. But then, what are the limitations of freeze drying your pharmaceutical product? Okay, you cannot freeze dry any kind of drug molecule. Your drug molecule should be stable without presence of water. Okay, but some drug molecules will not be able to stay without water molecule. Then you cannot freeze dry. Okay, so like things like cephalosporin, maybe it's kind of antibiotics, cannot be freeze dried because it requires water. If you remove water completely, maybe drug can be denatured or inactivated. Okay. So many biological molecules are susceptible for stress associated with the freezing process or freeze drying process. So if your molecule, API molecule, is very susceptible, fragile, denatured or degraded during freezing drying process itself, then of course you cannot freeze dry your drug product. And then additional lengthy and complex manufacturing process, because you're adding one more step in your drug manufacturing process, which you have seen, aseptic filling, isolator, and then a stoppering. And before going through the sealing, you have to add the freeze drying process. So, for you to be able to do that, there should be a huge manufacturing scale of freeze dryer attached to your vial filling machine. So the cost of adding that capacity is very expensive normally. Okay, so it's a lot of money we're talking about, and a lot of GMP, of course, validation burden if you add one more step in your manufacturing process. That could be a advantage. So you have to see which one is more beneficial for your manufacturing process. Okay. And what can be freeze dried? Okay, so some small molecules that are non-biologic and some biological molecules, okay, freeze dried. For example, vaccines can be freeze dried, and enzymes can be freeze dried. Hormones, vitamins, blood-related products like plasma we talked about. Antibodies can be also freeze dried. Tissue for surgery. Some tissues can be freeze dried and reconstituted. And the food material, as I said, seed culture, some seed can be also freeze dried and preserved for a long time. And museum specimen, like a taxidermy kind of things, and the oil-rich products could be sugar-rich material, salt-rich material. So there are quite a lot of different products that can be freeze dried. Okay. So then let's talk about the freeze drying principle. So freeze drying is possible because of this process called sublimation. Sublimation. Okay, it's hard to say. So sublimation is a process where ice crystal is vaporized directly. Okay, so you all know that water has three different states or conditions. Okay, water can exist as liquid, or it can be crystallized, or it can be vaporized. There are three different forms, right? So water or liquid can be crystallized if the temperatures are going down. That's simple, right? And then liquid can be vaporized if you heat it up. So it's the temperature that changes, the crystal form to liquid form, from liquid form to vapor form, gas form, right? So that's the temperature is the main factor. Okay, but if you combine that temperature factor with maybe pressure factor, okay, then you can do more control. So let's say water is frozen first, so liquid is crystallized, okay, and then what happens if you drop down the pressure? Okay, so then what happens? So maybe here, okay, so maybe it still is a crystal water, okay, and from there now you can slowly heat up your crystallized liquid and see what happens. Okay, so especially it's not going to go through the liquid state. Instead, it's going to go directly to the vapor state. So crystallized water can go directly to a vapor state. So that is the process we call sublimation. Okay, sublimation. So solid water, crystal, can be vaporized directly without going through liquid. That's sublimation. Okay, so that's what you're talking about. So when you freeze dry, you have to freeze your water liquid into crystal form, and then you slowly heat it up under that same vacuum condition, high pressure condition. Then your water crystal will be vaporized. That's sublimation. So that's the principle of your freeze drying process. Okay, so instead of going through the liquid condition, you can remove water crystal from your drug as vapor form. That's how it works. Okay, so let's talk about what happens if you freeze dry your drug product. Okay, so physical properties of materials during freeze drying condition. Okay, so you have a formulated drug that contains your API molecule as well as some excipients like salts and some stabilizers or preservatives and some other chemicals that mixed up together with your API, right? So water, API and a lot of excipients mixed up together. That's what your drug is. Okay, so then when you freeze your drug, then what happens? Okay, so actually your pure water molecules will be crystallized together. So we call that nucleation of water and crystallization, meaning water molecules hold together among themselves as pure water. Okay, that's water molecules getting together is nucleation, and the crystallization is maybe they are getting frozen. Okay, so water molecules are coming together through that hydrogen bonding, and then they form a stable nucleus. That's what it is, and then they become crystal. So they become water crystal among themselves. So if you look at this under the microscope, maybe you will see that these are the channels of water molecule network. Maybe crystallized water molecules. So if that is the entire drug, okay, so the water molecules will come together only among themselves, and they form network of crystallized water. So that's what happens, crystalline water structure. And then what happens to the rest of them, like API and other excipients? They are kind of pushed away from water. Okay, they will stay together among themselves. And then the important part is under what condition, how these other things, the API and excipients, will stay together in what kind of a crystal form. That is the very important question about this sublimation process or freeze drying process. Okay, are they going to exist as stable kind of form? Then we call them maybe eutectic mixture condition. Okay, or are they going to exist as some kind of glassy form, or are they going to exist as amorphous form that are unstable? That's another possibility. So we'll talk about those. Okay, so anyway, we call these spaces interstitial space. That's where you'll be able to find your drug and other excipients mixed up together. Okay.